Good day, student. Good day, my learners all over the world, those who have been following my YouTube channel. Okay, so I want to believe and hope you have been following up my YouTube channel. And if this is your first time you come across to with this channel, I will encourage you to share it with people, subscribe to this YouTube channel, and also share to others, and whenever I upload new videos you will be duly notified. Okay, here is a question on the reaction mechanism, chemical kinetics and reaction mechanism. I have actually spoke about I've uploaded video on chemical kinetics, first order, second order, zero order, pseudo order of reaction, and in terms of the integrated rate law and their half-life. I've also talked about their graphical different graphical ways of determining order of reaction. Okay, here is a reaction mechanism. I've talked about reaction mechanism, how to determine intermediate, how to determine the rate determining step, the rate law, and other. But here is a question. I'll be uploading many questions, okay, on reaction mechanism that have been giving problems to students all over the world. I've listened to students sending me text messages and complaints. Those who know me and have my number called, and I want to make justice to some of these questions. Okay, here is a question before us that we are asked to deduce the rate law to be expected for the overall gaseous reaction. Okay, it's term gaseous, so of course you should know. I'm writing with pen, I may not be able to put the state of matter. Okay, so this is the reaction. Okay, I told you in reaction mechanism, reaction that you see here does not mean that this is actually what happened. They are elementary reactions, steps of reaction that have taken place, and the steps of the reaction are the mechanism of the reaction, that is what you are seeing here, the fast process and the slow process. Okay, these are the mechanisms that make up this reaction. How do you know? If you add these mechanisms together, step one and step two, you are going to have the overall reaction. Okay, and we are asked to determine the rate law here. To determine the rate law, you look at this process. This is a fast process, step one. This is a slow process, step two. And for my previous video, I've told you that the slow process is usually the rate determining step. But please note, it is the slowest process. We can have many slow process in the mechanism, but the slowest of them gives you the rate determining step. And also note that even though it is a general law that the slowest of the mechanism gives you the rate determining step, there are other ways questions can be set where to confuse students. Okay, questions like that, they may hide the slowest reaction and possibly make it the fast reaction. Okay, so that the student will not be able to quickly determine the rate determining step. So but anything that is intelligent, we should be able to know the rate determining step, not solely depending. Please note, understand what my statement is, not solely depending. The slowest step in every question you see is the rate determining step. The reason is because examiners may want to put you in confusion by setting questions that oppose that law. In that case, you should know what to do. In any case, there are questions I'll be bringing up on that, but let's just focus on this. Now, we have the fast process. In my previous video, I told you that the fast process, most time, it used to be, reversible like this. Okay, then you have N2O2. Okay, so this one you have N2O2 plus Cl2 to give you a 2NOCl. You can see. Okay, now that means I'm going to have my rate constant 1 here, and this I say rate constant superscript of -1 and rate constant 2. Okay, so the first thing to do in determining rate law of the reaction mechanism, okay, is to first of all write the rate law of each of the elementary step. Here there are three reactions taking place here. This is the forward reaction, this is the backward reaction, then plus this one. Okay, we are told this is the slow and this is what the fast. And understand this will become our rate determining step. Okay, you will know why it is so later. Now if you take the first and the rate law for the first reaction, R1 will be equal to the rate constant K1, then the concentration of NO raised to the power of 2. Do you understand? Then, if you take for the reverse reaction, which is for the reverse now, which is here, you are going to have K minus 1, okay? You have N2O2, okay? Then the last one is R2, which will give you K2, N2O2, then Cl2. Do you understand that? So you have written the rate law of each of them has been written. There is a mark that will be awarded for each of these. Now, after writing this, the next thing you are required to do, I told you number one, write the rate law for each of the elementary step. This next step, try to identify the intermediate. Okay, identify the intermediate. The intermediate here, the intermediate, if you go to my previous video, the intermediate here is the one that is produced in the element in the early stage of the elementary process and then later consumed in the later stage. So the intermediate here is N2O2. So our intermediate here is what? N2O2. Sometimes you can have more than one intermediate. Okay, having gotten your intermediate, the next thing is to apply steady state. Apply steady state approximation. I have explained steady state approximation in my previous video, so I will not be going into that now. The next thing is to apply steady state. In applying steady state approximation, you are simply equating, okay, this to this, where you are equating reactions together so that you can make your intermediate the subject of the formula. In short, that is the reason why you are even applying the steady state. When you equate it now, when you equate this to this, where you have the reversible, you will see that your intermediate will appear. Then you make the intermediate the subject of the formula, and that will give you R1 is equal to what? R minus 1. When you do that, you shall be having what is my R1, K1, concentration of 2 square, then K minus 1, which is this. This is my equation 1, this is equation 2, this is equation 3. So I am equating 1 and 2 together, which will now give me this N2O2. So here I will make what now? My intermediate, the subject of this is my intermediate here. So you make number 4, make intermediate subject of the formula. And when you do that from here, okay, you will divide both sides by K minus 1. Then you are going to be having your intermediate, okay, to be equal to K1 over K minus 1. Then the concentration of N2 square. Remember, this is your intermediate, okay. This is your intermediate. Then the step thing is in number 5. You identify your rate determining step. Identify the so your rate determining step here, I told you the slow process, but let me hide that word slow process. Rate determining step, most time, what you find in the rate determining step is the intermediate. Okay, please note that your intermediate is always in the rate determining step for the sake of substitution. Look at this intermediate now that you made the subject of the formula. Where can you find it here? You can find it here. Okay, for the sake of substitution, you will make use of R1 and R minus 1 by equating them together. This is the only one you have not made use of. Okay, so because of that, you will now let's call this equation 4. Equation 4. If this is equation 4, let me say identify my rate determining step. My R2 is equal to K2 N2O2 Cl2. This is my rate determining equation. Meanwhile, my rate determining step is the step 2. Here, I think you can see the way I'm pointing my pen. This is my rate determining step. Why this is the rate determining equation? So this rate determining equation actually is the one that will lead to the final product. Okay, you can see a product here. So if you substitute, number 6 now is substitution. So if you substitute equation 4 into where equation 3, that means put 4 into 3. When you do that, remember this is equation 4 and this is equation 3. And what are you doing? You are substituting this one into here. So you are going to be having R2 is equal to what? R2 is equal to K2. What is this? Everything here, which is K1 over K minus 1. Then what is this? Or it's also here. NO square. Then remaining what now? Concentration of Cl2. Do you understand? You see the way I've done it now. After substitution, then you have K2, you have different rate constant. So you assume let K2 K1 over K minus 1 is equal to K. When you assume that, okay, that means our R, even R2 will be equal to R. So that means our R will now be equal to everything here is for K, then NO square, then you have Cl2. This is the rate law for this overall reaction. The overall reaction is given to you already, okay? So this is the rate law for the overall reaction. Normally, if you are going to write rate law for this, how would you have written it? It is to say R is equal to rate constant, which is the concentration of NO raised to the power of these two, then concentration of Cl2, which match. Now, sometimes the overall reaction will not be given to you, or the net reaction, okay, will not be given to you. But how do you get the plausible net reaction? How to get that is to add all the elementary steps together. This is the first mechanism, this is the second mechanism, or the first step, the second step. When you add them together, okay, then cancel at the identical species. I have treated this in my last video. You get overall reaction. Let me just introduce it here. Look at this. I am adding this, which is 2NO plus this reactant here, N2O2 plus Cl2 will give me what? N2O2 N2O2 plus what? 2NOCl. You see what I get here now? I hope this is visible for you. My handwriting is small. Yeah, N2O2 will cancel N2O2. So that I will be left with what now? 2NO plus Cl2 to give me what now? 2NOCl. Remember, this is our rate and this is our overall reaction, which is equal to this. So remember that the overall reaction, most time, the overall reaction, okay, will be balanced. You don't need to balance it. You don't need to be balancing stoichiometrically with adding 1 or 2 or 3 somewhere. It will balance on its own, okay? So that is it. Now, if you go back to our rate determining step, I told you that rate determining step usually is the one that lead to the final product. If you look at it, we say this is our rate determining step. It leads to the final product. If we go to the overall reaction, they did not give you the final product, it gave you the final product. That means this is our rate determining step. I have tried to give you different ways of identifying the rate determining step. Sometimes it is the slow process, okay? I mean, generally, rather, it is the slowest process of the reaction, but some questions will come up where you will begin to see that the slowest process is not even the rate determining step because the examiner has twisted the question so that you will not be able to quickly identify it. But generally, if you are teaching, you should make students understand that the slowest process is the rate determining step, okay? Then in this case, the slowest way is the rate determining step, and it leads to the final product. Another way you will know that the rate determining step is how is that the rate determining step leads to the final product. Okay, it is the step that leads to the final product, and if you look at it, these are rate determining steps that result to the production of NOCl. And if you look at our overall reaction, you can see NOCl. So this will be the rate determining step. I want to believe you understand what I've explained, and if you do, I want you to show it by put some likes on the video, and also share this video to other students, chemistry students, of lower learning and higher learning, undergraduates, graduates, and postgraduate students. Okay, I find that this area of mechanism have been a challenge to some person. Thank you, and God bless.